the compiler, the row line compiler. And so we're looking at an arrangement in which we utilize the basic row line infrastructure underneath the implementation of Casper. So there's like a secondary implementation that is utilized. There's a secondary implementation of the tuple space semantics that sits above Casper, and then there's one. It's kind of like a sandwich, right? So there's a lower level one that provides COM and storage to implement Casper itself, and then Casper sits above that. And then there's another implementation of the actual target of the contract semantics that can then rely upon consensus for the I/O interactions. Maybe next week I'll provide a diagram of that, but that's primarily what we've been focusing on.
And
It's
going to be a row calculus VM as well.
Yeah, that's right. So what that way we get to write the communication protocols as at the lower levels, without having to worry. It's just like having a gossip layer and then writing your consensus protocol over top of the gossip layer.
Yeah, that's kind of the way things go in single consensus protocol land.
Yeah. It's
really cool.
Yeah.
Have you made any does the construction for the consensus protocol fall out of your trace definition?
Can you guys hear me?
No, I didn't hear any response to. Did you hear?
Okay, I didn't hear your question because I had to switch networks again.
Oh, I just wondered. I wonder if the kind of construction for the consensus protocol, somehow if that somehow falls out of your kind of trace monadial category definition, or do you have a problem there that you need to solve and find something that type checks in order to kind of implement the VM?
No. So the trace monadial category informs the types of the contracts that are implementing the Casper protocols. So if you look at the layer diagram, right? So there's kind of this core row-like semantics that sits on top of a tuple space that has a local store and a communications layer, right? And then there's Casper, the Casper implementation, and then there's another row-like semantics that the contract semantics takes contract semantics that depend upon consensus utilized. And so the system level contracts that implement Casper, they have types, and those types are informed by the types given by the trace monadial category. Now, the trace monadial category construction, it doesn't pick out a specific consensus, right? It says, if you have these types, then we know what you do is a form of consensus. But it doesn't say, right?
But does it help you know how to put those parts together to make a RoCalc VM?
Yeah, that's to make the VM itself. I don't think so, but that's an interesting idea.
Okay, I'm just wondering if you have what.
Well, this is kind of what. Yeah, this is kind of what Mike and I were thinking through a week or so back, where the question was, do you get is there an internal language for the kind of categorical construction that we have? Because if there is, then you can auto derive a VM for that. Now, the likelihood that it seems unlikely to me that that would be a direct comparison to the Rho VM, but it might be. It might be. It's an interesting thought. So if you look in if you look in computational interpretations of linear logic, so Samson kind of does this thing, 3 times. So he starts with intuitionistic logic, and then derives a virtual machine that is faithful with respect to the implied computational model. And then he moves to intuitionistic linear logic and does the same thing. So he derives a virtual machine whose semantics is faithful with respect to the implied computational model in intuitionistic linear logic. And then he does a similar thing for classical linear logic. So under the assumption that you could that for the trace monoidal setting, that you could do something similar. And it's not completely out of the question that that's possible. Then you would have this derived virtual machine, and then you could compare that to the Rho VM. I think that's interesting.
Yeah, I mean that would be cool. But yeah,
I'm just worried about expressive power. I think that Rho VM is just it has a more fine-grained notion of what computation is, and so it's going to be able to say things.
Yeah. So like for me, and with my like kind of correct by construction kind of process for defining consensus protocols, like I have to basically like re-rig certain definitions for every new use case in order to kind of get a consensus protocol for it. So like I would have to like do like maybe quite different things when I'm replicating the Rho VM than when I'm replicating a bit or a blockchain.
Yeah. We talked about that a little bit, about what in particular is the relevant thing that the canonical estimator is going to have to do. But
yeah. So usually it's something that you want to say you can meaningfully say is going to be true in all future states of the protocol. So like for example, the latest block is X is like hopefully not going to ever be true for all future states of the protocol, because like we will kind of progress to new latest blocks. But the block at height H is X is something that is like suitable to be an estimate in this from the point of view of the estimate safety definition, because it's possible for it to be kind of an invariant in all possible futures. So again, like the latest block has this hash. It's not a very good estimate, but the block at height X has this hash is a reasonable one. So for the row calculus, you would basically want a similar kind of thing in your estimator, where for example, like so imagine if every communication event was like kind of a unique identifier based on like the sender and the receiver channels. So like somehow I don't know. So I mean, basically, what you need to do is like say how race conditions were resolved, say at least, right? And you need to say, okay, like this race condition was resolved like that, and that one was resolved like this, and you might end up actually having, a whole bunch of independent decisions that you need to make, and that might not end up being too difficult in terms of the adversary calculation.
I mean, I think that the thing with respect to the adversary calculation that we get to take advantage of is the name spacing will at least provide you information about conflict versus order.
Mm-hmm. Yeah, no, it sounds it's the more kind of the less information is relevant for calculating safety, the easier it is in this kind of fundamental way.
Yeah. So that's my update. Vlad, do you want to give an update?
I don't have too much of an update this week. Vitalik and I have been working on some sharding stuff a little bit, just like talking about the various problems. Vitalik's really kind of gotten a lot of motivation to work on sharding now because of the increased transaction count in Ethereum. We're the main debate that we're having, and is something where I wish Vitalik was here so he could speak to. Is between kind of having shards run as concurrent consensus protocols or having a consensus protocol, like a single one, over the state of all the shards. He kind of prefers the latter because he says it is safer and not a significant increase in overhead. Whereas I kind of prefer the forward model. I haven't 100% been able to say exactly, why in a super compelling way, other than to say that there's more concurrency. The kind of shards are a little more independent, and there is less overhead, because at least,
Yeah.
There's at least a constant factor less overhead. Say if you're using like a 2/3 safety threshold.
Yeah, I see.
Because
what's the granularity on syncing the shards?
Every block, you can imagine that there's one. You can imagine that there's one block every for every shard. I mean, I'm pretty sure that's what's I mean, maybe certain shards won't be updated, but basically, you can only have one block per shard per global time click.
Oh, okay.
And so basically, it's it's designed to be, to have to shard validation, rather than consensus, which I think is interesting, but somehow I'm much more comfortable with the model where I just have where I have a bunch of consensus protocols and I'm kind of tying them together to make them, implement certain, atomicity and censorship resistance things. As opposed to starting with the state and under a single consensus protocol and breaking it up into different shards. I think potentially both are valid and reasonable things to do, and that in the end we will want both because
well, they're interrelated, right? I mean, the state of, let's say you have two different networks, right? If you combine the networks, then the state of one and the state of the other is part of the state of the combined network.
Yeah, right? but the way in which they're
the protocol that's used by one and the protocol that's used by the other is now part of a larger protocol, but that's used by the combined network. So they're completely interrelated, and then this becomes very interesting when there's a transaction that spans both networks, right? That's when you in order to see the state of the total network, you have to consider the protocol of the combined network, so the combined protocol. So
the kind of difference between Vitalik's version and my version of sharding at the moment is the manner in which the shards have to synchronize and in order in the consensus process. I kind of have a consensus between consensus protocols, and he just has one big consensus protocol. So yeah, I'm not sure. I mean, it might be composable, and we might be able to have both and may have transactions between them. I mean, I'm pretty sure we would. but it somehow it's still an interesting conversation that I think it kind of is as much a question of like like theory and like hard numbers in terms of like kind of overhead, uh, as much as like kind of ease of deployment and kind of iteration, right? Because in if we're gonna need a scalability solution in the short term, it would be probably easier to implement metallics that than to have like these things that are synchronized less often.
Yeah. Well, it's a lot easier to write a sequential machine than it is to write a parallel machine.
Yeah. This does it does parallel, but basically everything's on kind of like a clock and on the global level.
Yeah. Yeah. Understood.
Yeah, it's totally something where, I mean, that's basically, I guess, the main research thing that I've focused on this week. As far as I can recall. So, yeah, I mean, I was kind of in transit, and now I'm actually in Seattle, so we should hang out.
Yeah.
Last night.
Cool. Well, if you want to meet up with Kent and I today, we're probably going to hang out at Ladro.
Cool. I'm probably gonna like nap after this.
Yeah. Yeah.
But I'll let you know.
Cool.
Carl, do you have any updates?
Yeah. So 2 updates. One is just like implementation side, getting to a point where it can be like reviewed and gone over so that there's like a kind of complete working piece of code that can then be checked for kind of oddities and potentially better ways to do things. So that'll be exciting. And the other kind of update, and I will definitely like post links when that is pretty ready. And the other side of things is I gave a I gave a Casper, the friendly finality gadget, plus smart contract consensus talk to presentation to internal to consensus. And it's like it was booked for an hour, but it went like way over to an hour and like 40 minutes or something, and there were like massive amounts of questions. So it was good, and I think a good kind of like potentially learning. It could be good for learning just because there were so many questions. Maybe a lot of things were covered.
That's cool. That's really cool.
Yeah. So I think consensus wants to publish it as like a blog post or something like that. So I'm gonna like kind of get it ready for being published and make sure that it's like
a recording or your slides. Like
a recording.
Cool.
I can actually I can send a link to my slides.
Cool. That sounds awesome. Yeah. It just I just got tripped up on the publishing a blog of a recording thing.
Oh yeah. No, it would be like a blog that has the slides and the recording.
Yeah, that's cool. So what were some of the takeaways from the process?
Well, one takeaway was a lot of interest in like transaction censorship. People were like, oh, like what about censoring transactions, just like normal transactions, or all that kind of stuff. Another takeaway was maybe we need some good mental models for how to explain Well, I don't know. I think there are definitely a lot of mental models that could be improved. I tried to do a few. I think one that went well was I did this smart contract. I mean, consensus in a smart contract where I have this. You know what? I'll just share my screen just for funs.
Okay, cool.
And okay, here. So I had this like slide, how to visualize yourself as a consensus forming contract. And basically each block can see its own history. So I did these like silly little things to kind of illustrate, get yourself in the viewpoint of like, I am a smart contract and there are many kind of different states which I can occupy, but I always can only see like one chain of blocks behind. So I think that went well. Hopefully, I mean, I didn't get kind of direct feedback, but it seemed like people were understanding. And then I was like, how to visualize yourself as a validator choosing a fork. You can just like, the way that I do my fork choice right now is kind of the most like simple thing is I just like use the smart contract as a getter. So I don't actually have to re-implement any logic to kind of get any information. So I have this like, validator asking the smart contract for information. So anyway, yeah, so I'll post a bunch of I'll post these slides, and oh yeah, and I spent a lot of time on like finalization, which was I think people are actually really, oh yeah, that's a big takeaway. People are really excited for economic finality. And like for the kind of heartbeat or what every 100 blocks having some kind of certainty around blocks
the
not
reversion.
change. Yeah, the reversions. They're like that was like a huge. I mean, I spent a reasonable amount of time kind of trying to explain the economic finality points, and people were like super excited.
That's funny. So yeah, I mean, we've kind of known about it for a while. So I think the excitement internally has kind of worn off. But I can see why finality is kind of a big deal.
Yeah, exactly.
Yeah, there's this kind of ironic thing right now. I mean, so like when I like say if I was going to try to show someone how Vitalik's like consensus protocol works, like I would probably start by asking them if they know how PBFT works, which is way more complicated. And then if they don't, maybe I'll ask them about how Tendermint works, which is like more complicated also, but less complicated than PBFT. And I think I'm pretty sure PBFT is less complicated than Paxos, than multi-Paxos, right?
Yeah.
So basically, like and multi-Paxos is kind of, I guess, even more well known. And so there's like this weird, somehow the literature points you from like this most complicated possible protocol, to like this kind of much simpler protocol. And kind of the one of the things I like about the correct by construction approach is that it provides like a very different kind of angle from which to view the like consensus. And then the kind of like traditional question about whether the slashing rules lead to certain amount of overlap in the I mean that like there's a certain amount of slashing when two people when an inconsistent value is decided.
Yeah, exactly. It's like you don't really need all that literature to kind of understand the correct by construction, Casper.
Yeah, I think it's like it's more accessible, but maybe it is also potentially going to be harder to implement. But basically, it always depends on like what you do for the safety oracle. And I really like, I think we need to explore like that space for all sorts of different protocols and see, see if we find any kind of things that for some reason aren't like common. It would be cool to have like a general one, but at the same time, I feel like there would be like significant loss in performance if you have like a like a generic like a generic ideal adversary.
Yeah.
I guess Mike hasn't gone yet. Caller, are you done with your update?
Oh yeah, I'm done.
Cool.
So Carl, when you post that, where are you going to let people know about it? On the Slack channel or?
Which are you
The
saying?
blog
Slides
with your talk.
and stuff.
With the talk, that should I mean, I don't really know what like kind of consensus wants to do.
They'll definitely make it public as hell, though.
Yeah, they're definitely going to make it very public. That would be my estimate, my guess.
So I should be looking at consensus blog periodically to find this, or I guess maybe you'll let us know next time.
Yeah. I can I'll send a link in the chat.
In the first hangout after it's published.
Yeah, exactly.
Okay. Let's see. This week I worked with Greg on starting to formalize the ladle algorithm. We looked at Agda and Isabel and K-Framework and came to the conclusion that K-Framework had a whole bunch of features that we liked, was still being actively developed and supported. So we got in touch with Grigory Rosu, who is running the project, and we're going to talk to him tomorrow about how to do some of the things that we haven't been able to figure out yet from the documentation and tutorial.
Yeah, I noticed there was a K-Framework that was a nascent or in progress K-Framework spec for the EVM. That was kind of cool.
Yeah, so they're able to model all kinds of wonderful things. And in one of the papers, they model pi calculus, but they use a very odd mathematical syntax rather than the ASCII syntax from their actual tool. So I'm sure he'll be able to clear up how exactly they correspond when we talk on Tuesday. So from what I saw trying to use it, the issues weren't really about nominality so much as getting a normal form for the terms. And in the paper, I found out that they use a set construction rather than just the literal term itself. So they represent a term as having a set of input prefixed processes and a set of output prefixed processes, and then doing stuff with the sets. So a little bit of semantic interpretation going on there. But
we might be able to help.
Yeah.
Yeah. Nicely, K-Framework is written in Java, or was at least originally written in Java. And then the academic version has been completely rewritten in Scala. And then they have a commercial version that's a mix of Scala and Java. And apparently they now have customers that include, trying to find where I was looking at this, they have customers that include NASA and Boeing and what did Grigory say? Do you have that email from him? Oh, here it is.
Look it up.
Here. Okay, no, that's just the scheduling one. Here it is. Okay, so yeah, so apparently, so the NASA, Boeing, Toyota, Denso are all using the K-Framework on large code bases. So they have a two forms. They have the academic form and then they have the commercial form. and so their match product is the commercial form, and apparently that runs about 10,000 times faster than the academic one. So that's very attractive, right? Because what we want is we want to really close the gap between our formal spec and our implementation. So if we can do the formal spec and something that's, Scala based, it makes it much more likely and much more possible that we can take the code that has been verified and with minor tweaks move it over to code that we put into production. That's the hope anyway. But that's one of the reasons we're talking to Grigori this week.
Yep, so that's all from me. I mean, I've been doing a bunch of implementation work as well.
Cool.
Cool. So we did the rounds. Do we want to go drill in deep on any topics?
I want to drill in deep on Wells Fargo.
Why? What happened?
I sold off a bunch of Bitcoin for fiat, and I went through an exchange, and they decided all the deposit activity on my account was suspicious, despite the fact that I have provenance of the transactions from the point of origin all the way out to photographic evidence and deposit receipts. And so they froze all my assets without warning.
Oh, no. Yeah, I mean, this is cryptocurrency for you,
Oh, I know, but it's just okay. Well, I've written to Governor Inslee, who has no love for Wells Fargo, right? I mean, Washington State is trying to divest of their engagements.
Greg, you should get a BitPay card, because I know that it's a prepaid card, so you load it with Bitcoin, and then you can go to an ATM and take out $2,000 cash at a time. And you can
that's not always like, if you're hiring people, it's not always like enough, right? You don't want to go.
Yeah, exactly. Anyway, so it was but it's just completely unreasonable for them to be, having all my assets in limbo. It's just
Yeah, I mean, but also, like, obviously you haven't drank enough Kool-Aid, am I right? What are you doing with fiat currency?
Yeah. I mean, no, I happen to have some large scale fiat transactions that I have to conduct. It's like, I agree with you 100% that normally, I've conducted my life almost entirely without fiat currency for like 3 years now. But in this particular case, I actually am forced to conduct some large scale transactions with fiat.
Yeah, that's rough. Yeah. Normally what I do is I'll try to find one of these services that will accept my Bitcoin and do an outgoing wire from their bank account.
Yeah.
And not to mine, because it's like it's like kind of a lot. It's a lot easier in some way.
Well, I mean, it was really useful because I got to see, like, looking into their process at this level was really fascinating, right? They wanted me to fax the evidence that I had. And I was like, wait, what decade are we in?
Century.
What century are we in? So it was really that part was fascinating. It was also fascinating because they kept giving me different answers. I had to speak with 15 different Wells Fargo employees, each one of which I had to bring up to speed on the situation. And each one of them had a different take. They had a different, some of them recommended I do this, some of them recommended I do that. They all had conflicting stories. So it doesn't give you a lot of confidence, right? Knowing that you're dealing with a financial institution that lost the class action suit. basically stealing money from customers, and is the target of another class action suit for stealing money from customers. Doesn't give you a lot of confidence. This is supposed to be the third party that you trust with your assets. And, it didn't make me feel confident. It didn't make me feel good about ever trusting them.
So this is actually like one of the biggest sources of demand for cryptocurrency is like people's like really like nightmare situations dealing with banks.
Kafkaesque kind of stuff, right?
I've heard lots of people come into cryptocurrency. I think you said this also when I remember like a couple of years ago, like cryptocurrency is like way more convenient than using bank accounts.
If Bitcoin never does anything other than to become a better PayPal, that's still a gigantic service, right?
Yeah. I mean, they've done it already for like a few thousand nerds. Like maybe if it can be done for a few million, that'd be even better. But it's still like definitely like made my life a lot easier in some ways.
Indeed.
Yeah.
So how do you guys pay mortgages, heating bills, etc. with Bitcoin?
Yeah, I mean, you rent and then you don't have those issues.
Yeah.
But I hear you. I mean, there's like but if you're willing to forego certain things in life, you can use the system.
A stable family's environment.
You can be stable and rent, right? It's not impossible. It's just basically like the question is like whether the wasted money that could be capital, quote unquote. There's that like classic case for why you should own a house.
Yeah, it is interesting that you can pay your taxes in Bitcoin in Utah. So that's fun.
That is interesting, really.
Yeah, 2014.
That's since 2014.
Yep.
They're ahead of the times. That's pretty cool.
That's really cool.
Which means it's real money according to the government now.
Yeah, that's actually pretty incredible, right? I mean, I think. Well, I mean, it's one. I mean, it's not. So like like there's like 7 properties of money, and like I have like pretty much a ranking of them, and like that one is like number 3. The top 2 are like unit for negotiating the amounts of the repayment of debt, and number 2 is a unit of account. So basically, like you're still not going to be agreeing with a tax pin on your tax bill denominated in Bitcoin. Right, you just pay as a medium of exchange in Bitcoin.
Yeah,
that's true.
And if that were ever to become the case, then it would be like then I would be like comfortable calling it money without fearing that I might be misleading people. The reason why I like put those at the top of the list is because like they're the ones that reduce the kind of cost of doing transaction the most out of all of the different kind of properties of money, at least like somehow to my mind. Any digital asset has most of the properties of money in terms of like divisibility, like fungibility, like transferability, portability, like these types of kind of basic properties. Medium of exchange, store of value, also relatively easy. Unit of account, you start to move to like impossibility status. Standard of debt repayment is like actually a really high standard, and I'm impressed that like that's true in Utah. But standard for negotiating debts is like also super hard. But what is this, a Bitcoin podcast?
Blasphemy.
in Ethereum, like I almost never ever think about monetary policy. I'm thinking about like kind of people implementing like things in smart contracts. Like to me, money is like an app rather than like like Ether. And that's not everyone likes to hear that, but like I think that like it's just realistic.
No, but I think it's really important to have that attitude, right? Because that's how once that becomes a much more prevalent mindset, then people can remember that money was about coordinating each other. It's not about the asset; it's about the coordination.
Mm-hmm.
That's
yeah.
And I think that will be of significant value as we have greater and greater demand to coordinate across a global scale to deal with some global problems that we're facing. So that's why I think that mindset and that attitude is extremely healthy given the situation that we're facing right now. So yeah, money is an app. Is a very, very healthy point of view. In my opinion.
I agree.
Yeah, I mean, I'm glad you feel that way. I mean, I feel that way, but also like, I also feel sometimes like people think I'm just being pedantic, which is like also fair enough from some point of view, but pedantry has its upsides.
You're technically correct, which is the best form of correct.
Okay. Anything else you want to touch on today?
Well, it's just more on the topic. We talk a little bit about stable coins and like the supply of stable coins. It's an interesting topic, basically because if stable coins are really much more useful in terms of reducing coordination costs than actually are cryptocurrencies, due to the fact that you don't need to like monitor balances and deal with cryptocurrency volatility.
Right.
And so like a smart contract that is able to like actually hold dollars is much more useful than a smart contract that holds Ether. And then the question is, okay, like what are the limits to the supply of dollars on Ethereum? And there's a number of them. One of them is basically for cryptocurrency collateralized stablecoins. Basically, you need just enough collateral in order to actually collateralize those assets.
Yeah.
And so like that imposes a limit on how many of them you can have be issued just from cryptocurrency collateral. Although of course you can provide more collateral, you can issue more tokens, and then like provide for this like ecosystem of people who want to use smart contracts. The other model is basically the kind of issuing on having a party issue tokens that correspond to dollars in their bank account, and this is kind of like an externally collateralized rather than cryptocurrency collateralized stablecoin. Apparently it's sometimes called e-money in the real world, but I call them stablecoins. If externally collateralized stablecoins. Because like from the point of view of the blockchain, like the blockchain can't really tell how the redemption is happening, but like there is a redemption function and like coins get destroyed and it doesn't really know what's happening on the other end. But like in a cryptocurrency collateralized thing, there's like some smart contract on the blockchain that like will very much process that redemption by delivering cryptocurrency.
Right.
And so like that, from my point of view, there's like two worlds, like internal and external redemption of these things. And basically in the external world, basically you have like kind of the Wells Fargo problem of like, what if the bank decides like, that it doesn't like what you're doing? And then like, and which is kind of inevitable at some point if we're talking about the supply of fiat currency that we actually need to be on the blockchain to exploit the utility of smart contracts. And so it's interesting because this basically points to the fact that we're going to have limited supply of stablecoins, which I think is going to mean that they're overvalued and not stable actually, because like people would rather buy one of them than like send a wire into the system to create them, or maybe they would rather sell them cheaper rather than use the fiat to get out. So actually, like, it won't be, so like the stability will suffer due to the fact that there are limits to the supply, right? So
That's
go on.
pretty ironic, right?
Yeah, definitely. I feel like I feel like almost calling something like a stable token or a stable coin, like it's a little bit misleading, because I think the natural state for any kind of value transfer is definitely not stable. So I mean, it's always like stable relative to something else.
Yeah, it's always tracking some price oracle, as far as I kind of think about it.
Yeah.
Whether the price oracle is actually like explicitly an oracle contract or not.
Yeah, so I feel like almost, I mean, we do want to achieve some level of stability, and definitely more stability than we currently have with like fluctuations in the price of ETH or whatever, so we can start paying people. But I think that it's just like it's a healthy concept to think of money as an app. I think it's also probably a healthy concept to think of coins as what they are, like a coordination mechanism, and that they have a little bit more of a nuanced understanding of value. Because I think, I mean, for instance, one example of this, right, is the internet probably gave us a more nuanced understanding of truth. So.
or undermined any understanding of truth that we have. One of the two. I don't know.
Well, if we're not doing something like that, then we're doing it wrong. So.
Yeah, but so like I mean, I think I hear you in some way, but also I think that like it's kind of like you better have a really good excuse if you're calling for revolution.
Okay, you're right.
So, Vlad, I'd like to invite you to a talk with one of my friends who is working on a stablecoin project. They're using two blockchains to keep the overall currency stable. I'd like you to be in that conversation if that's possible. I don't know when you're available. It's not a big deal.
Sorry. I didn't understand what is stable relative to what. Is this like one blockchain tracks the value of the other, or what's the story?
You're gonna have to talk to him because it's not my project, but I'd like you to be in that conversation because he's kind of a brilliant guy. It's obviously
Peter.
No, this is somebody else, totally different. I'd also like you to talk to him, but it's not in the cards yet. It's a few months down the line. Anyways.
Okay, well, no, let me know, and I'll take a look. I mean, I generally like try not to, give free advice or look at projects because there's so many projects, and at this it does take a significant amount of time for me to like go in and become familiar with like their failure modes. Although
yeah, I think it's more just
I do hone in pretty fast.
I think it's more just like a Skype conversation for like 30, 40 minutes. It's not like hours of research and, anything like that. It's not necessary.
Okay. Yeah. So, I'm optimistic though that demand for stablecoins will lead to the supply of stablecoins in some way. At least if possible, if like it's a thing that people can do, and basically like, I think that like either way, somehow stablecoins are less good than native blockchain tokens. The only way to make it like as good is to have like actual fiat on the blockchain. So like, there is like some case to be made that like somehow the native tokens are the best from a security point of view, but not necessarily from a usability point of view, unless we had like literal actual fiat on the blockchain, which would be like pretty remarkable, but also something that like, I think a bunch of people in the blockchain space wouldn't really like. Am I right, Carl?
I would say so.
I think overall it would be quite good because of the whole smart contracts being more useful, faster thing. But also, like, let's not put the cart ahead of the horse and figure out blockchain scaling first.
Yeah, absolutely.
Yeah, I mean, blockchain scaling, I think, is still somehow one of the bigger issues.
Somehow. I don't know how you came to that conclusion.
Mildly.
Yeah.
Yeah. Well,
but, I mean, somehow meaning like, oh, we've been working on it for so long, like, shouldn't it be solved by now? And I mean, like, it kind of, we have made progress, but we still have like a lot of trade-offs. Basically, the interesting, there's a few interesting things. One of them is like, okay, what do we release in like 20 years, and then like, what do we want to release like, sooner?
Yeah.
It's a very different kind of thinking.
Yeah, absolutely. I mean, I think even with the the formal methods, there's going to be what you release now versus in 5 years from now, and how much of it, because you have to give people something they can play with so that it becomes more tangible. But it's not going to be vetted from end to end. And so, but the nice thing is that all of the compositionality and modularity is also all about breaking it up into bite-sized pieces that you can tackle in terms of the formal verification. So the very same things that the very same techniques that are applicable to scaling are also applicable to scaling the effort to verify. It always comes down to breaking things up into bite-sized pieces so you can assess the risk, right? That's what engineers do. So.
Yeah, I mean, that makes some sense for sure. It's going to be interesting. I hope that the cursive backwards compatibility won't be too strong. That's actually my biggest fear about all this stuff is like backwards compatibility.
I was talking with Joe Lubin and Jeremy a couple weeks back, and they were talking about different ways that we can start to jumpstart the Archain Ethereum relationship, and there were kind of two different paths on the table. So one path was to take Rolang and compile it to EVM. The other path was to take Solidity and compile it to the Rovium. And of course, there's transpilers as well, but those are more or less the same result, right? And it really comes down to a kind of trade-off, right? So if what you're trying to do is to teach developers the mindset of programming in contracts that have internal concurrency, then it makes sense to present a facade that is Rolang, even though the semantics in the back end is an interleaving semantics over a single-threaded execution model. The other way is a little is interesting. The Solidity semantics is not really multi-threaded, right? So you'll take a multi-threaded semantics and you'll preserve it over on the Rovium, and it won't run any faster. So that's those are the kind of trade-offs that we were looking at in the discussion.
Yeah, so that's the cost of compatibility, right? And I feel like backwards compatibility is like a very similar type of thing. Also,
except that we're not at a state where there's significant commercial applications on top of Ethereum, right? There aren't.
Tell that to consensus. Am I right?
And the longer we go, the more difficult that problem gets, right?
Mm-hmm. Yeah, I agree totally. I mean, but basically, like, we're gonna end up, kind of being a little like Windows, having this entire backwards compatibility like thing in every release.
Yeah, I think that's it entirely. So, yeah. I mean,
I mean, that's kind of like,
consensus was becoming the man in this conversation. The proverbial, stick it to the man. Consensus was becoming the man in that conversation, right? Because they had this heavy backwards compatibility albatross, and so it's an interesting place to be in the decentralization space.
Yeah, I mean, it's interesting. The network effects and centralization have always been a part of the decentralization space.
Yeah,
in this kind of like funny way. One blockchain to rule them all. Am I right? Like I've since moderated my opinion from one to a small handful.
Yeah, it's never going to be one. It was never ever going to be one.
Yeah, I mean, I totally hear that, and I mean, I didn't really believe it until I met Vitalik. And he convinced me that Bitcoin's network effects were, not all that the Bitcoiners made them out to be.
Yeah, I think that's correct. I think that's correct. And network effects, they're more volatile than you might think in general, right? I mean, so suppose that in 3 months' time, a network comes out that has 40,000 transactions per second and can guarantee, the same kinds of, provide the same kinds of transactional guarantees.
Yeah.
Right.
Yeah. So this is, and I mean, like, you say that, but like people are actually like claiming this kind of stuff, and they're doing it with like much less than like the same type of guarantees.
I understand, but the word will start to get out, right? I mean, the more, because what happens is you start being able to write applications that you couldn't write before.
Yeah, of course.
And then the developers, they'll vote with their feet, right?
Yeah, I mean, at some point, even the fees will lead to like people moving to whatever is the most scalable.
Oh, that's exactly right. That's exactly right. I mean, already the whole run up on cryptocurrency has just eaten a lot of people alive on fees.
Yeah, absolutely. Yeah, but it's always got to be couched as good news, Greg.
Oh, it is good news. I'm not saying it's bad news.
No, I'm just playing. I mean, I'm just playing. I don't think it's good news. I think it's bad news. I mean, I think like it would have been great if people just like held off and like treated cryptocurrency as more of a spectator sport for a few more years.
Yeah, fair.
But I guess that they also have like real reasons to use it in some cases.
Oh yeah, well, yeah, not the least of which is Wells Fargo.
I'm sure they have a blockchain team.
I bet they do. Anyway, on that note, I really should jump off. I've got a meeting in an hour, and I've got to prepare.
Okay. So yeah, it's been fun, even though we didn't have most updates in the world this week. Cheers, everyone.
Yeah.
Cheers.
Yeah. Ping me when you want to get together.
Yeah. So I will do.
All right.
Bye, guys.
Ciao.
Bye.